Hello. These notes are going over how to create equivalent fractions. Equivalent is a math word that just means equal. So the goal of what we're doing is to create fractions that are the same amount, but they're cut into either more or fewer pieces. We can use a visual to find equivalent fractions by adding or removing lines that go through all of the pieces. Let's look at our first example. It says 2/4. So I'm going to color in 2 pieces to show that 2 of the 4 pieces are colored in. If I get rid of that red line down the middle and I still keep the same amount colored in, all of a sudden we have the fraction 1/2. It is still the same amount, it's just one bigger piece colored in instead of 2 smaller pieces colored in. If we add another red line going through all of the pieces and color in the same amount of the rectangle, that would be 1, 2, 3 pieces colored in out of 1, 2, 3, 4, 5, 6 total pieces. So that would make our fraction 3/6. Again, if you look at all the rectangles, you can tell they are all the same amount, just in smaller pieces for 3/6, slightly bigger pieces for 2/4, and one really large piece for 1/2. You're going to try another example on your own. You're going to start with a medium-sized fraction in the middle, and then you're going to make a smaller fraction and a larger fraction on either side that are still equivalent and the same amount, but just look different because they're cut in different size pieces. Our first example says 2/6 or 2/6. If I was going to color that in on our visual, I would color in 2 squares and I would make sure my diagram is cut in 6 different pieces. To make a smaller fraction, I would take away this middle line and I would just color in this one rectangle. That would make this fraction 1/3 because one piece is colored in out of 3 total pieces. If I go the other direction and I add another line going through all of the pieces, I would color in 3 squares or 3 pieces because it would still be this same vertical chunk of my rectangle, and that would be 3 pieces out of 1, 2, 3, 4, 5, 6, 7, 8, 9. So my fraction would be 3 out of 9 or 3/9. There are 2 more examples like this before we practice doing this with mathematically instead of using a visual. So try those next 2 examples and push play on the video when you're ready to check your answers. Our next fraction is 6/8, which means I need to cut a rectangle into 8 pieces and color in 6 of them. So here I go. 1, 2, 3, 4, 5, 6. Okay. If I color in those same vertical pieces but remove that middle red line, this is what my fraction would look like now. And that fraction is 3 pieces colored in out of 4 total pieces. So 3/4 and 6/8 are equivalent fractions. To make a bigger equivalent fraction, I could color in those same vertical pieces. 1, 2, 3. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces colored in out of 12 total pieces that are available. I hope maybe we might start to notice a pattern that we are going up in multiples of our denominators. So this fraction is this fraction if we times the top and the bottom by 2. Our larger fraction is the same as our smaller fraction if we times the denominator and the numerator by 3. Same thing on this example. If I times this fraction by 2, I get 6/8. And if I times this fraction by 3, I get 9/12. Let's try that method on the bottom fraction and see if it works. If I do this fraction as a visual, I will get 4 pieces colored in out of the 10 pieces that I made. So I split my rectangle in 10 pieces and now 4 of them are colored in. If I remove that middle line and I color in my 2 pieces, the fraction I get is 2 pieces colored in out of 5 total pieces. So my fraction is 2/5. If I do 2/5 times 2, I get 4/10. If I do 2/5 times 3, I would get 6/15. Let's color in our vertical pieces and see if we get the same answer using both methods. If I color in those two vertical pieces, I end up with 6 pieces colored in out of 15 total pieces. So both methods work. Take a moment to make sure you have this entire page filled in before we move on to the next page. On the next page, we will be using the multiplication method that I briefly talked about on the first page to make both bigger and smaller equivalent fractions. Just another reminder that equivalent means equal. So we are creating fractions that are the same amount but cut into fewer or more pieces. We do this by either multiplying or by dividing the top and the bottom of our fraction by the same number. So we're dividing or multiplying our numerator and our denominator by the same number. Take a look at this first example. If we started right here in the middle with 4/8, if we divide both those numbers by 2, we'd get 2/4, which is an equivalent fraction. If we divided by 2 again, we get 1/2, which is another equivalent fraction. If we come back to our starting point of 4/8, if I times that by 2, I get 8/16. If I times it by 2 again, I get 16/32. All 5 of those fractions are equivalent fractions. Some of them have really big pieces, like 1/2, and some of them have really teeny tiny pieces, such as 30 seconds. Now we're going to try some examples on your own. Let's try one more example together to make sure we're feeling good about this. If we start with 3/9, I need to figure out what is a number I can divide 3 and 9 by that both work out evenly. The first numbers I usually suggest trying are either 2 or 3. 3 divided by 2 would give me a decimal, so I don't think that's a good option. So we are going to try dividing by 3 on the top and the bottom, or the numerator and denominator of our fraction. 3 divided by 3 would equal 1. 9 divided by 3 would equal 3. So 1/3 is an equivalent fraction to 3/9. When we're looking at the times side to make it a larger fraction, I can multiply by any number I want, and as long as the number is the same on the top and the bottom, then I will always get an equivalent fraction. For this example, I'm just going to times by 2 because I like to multiply by smaller numbers and not get very large numbers. But if you chose to do a different number, again, as long as it's the same as the top and the bottom, you are totally fine to do that and you will still get an equivalent fraction. 3 times by 2 would give us 6. 9 times 2 is 18. So that is another equivalent fraction to 3/9. Go ahead and try the next 3 examples on your own, and then we will go over the answers. When you're ready to see the answers, push play. Looking at our last few examples, here's what we've got. 2/8. When I look at both of those numbers, they both divide by 2 because they're both even numbers. 2 divided by 2 would equal 1, and 8 divided by 2 would equal 4. So 1/4 and 2/8 are equivalent fractions. I decided I wanted to do something different than 2 on the multiply by side, so I did 3. 2 times 3 is 6, 8 times 3 is 24, so this is also an equivalent fraction to 2/8. Again, if you put a different number here that wasn't a 3, but you still multiplied by the same number times 2 and times 8 to get an equivalent fraction, that is still correct. On our next example, 4 and 6 again both divide by 2. 4 divided by 2 equals 2. 6 divided by 2 equals 3. So 2/3 and 4/6 are equivalent fractions. Again, I wanted to try a different number on my multiply by side to get a larger equivalent fraction, so I decided to multiply by 5. 4 times 5 equals 20. 6 times 5 equals 30. So 20 over 30 is an equivalent fraction to 4/6. Again, you might have a different answer on this side, and that's okay. As long as you multiply by the same number on the top and the bottom, you still came up with an equivalent fraction. For our last example, 5/10, dividing by 2 and dividing by 3 wouldn't work. The only number we can divide 5 and 10 by is actually 5. So if I do 5 divided by 5, I get 1. And if I do 10 divided by 5, I get 2. So 1/2 and 5/10 are equivalent fractions. We could do any number over here that multiply by. I decided to go for a pretty big number. I picked 10. 5 times 10 equals 50, and 10 times 10 equals 100. So 50 hundredths is an equivalent fraction to 5/10. Again, as long as you multiply by the same number on the top and bottom, and you have a different answer, your answer is still correct. Take a moment to make sure you have this page entirely completed.